So to solve this classwork, we will use an exact equation method to solve this problem. So I will go step by step. That is step 1 with rewrite the equation in differential form. Which I can write x plus sine y plus dy over dx. Or in other way, I can write x plus sine y dx plus x cos y minus 2y and dy equal to 0, and I note it as equation A. But you can see that this is mx y dx, and this one is nxy dy. So after that, I can check in my step 2 that check if equation A is exact by doing like this. The differential respect to y m x y, which is equal to, whereas m equal to x plus sine y. This means that we do the differential of this function with respect to y. So the other function we have to do derivative is sine y. So that is equal to cos y. And this is the derivative of m with respect to x is equal to x cos y minus, and in this case with respect to x, so either not x we are not count, and this is the we can derivative of this function with respect to x, so this is equal to cos y. Okay, cos y is here, cos y here is like a constant, so we get it cos y. Thus it means that the derivative of m respect to y is equal to the derivative of n respect to x, which means that it is exact. So we can use the exact method to solve this problem. So go to step 3, which is I suppose that s x y equal to c is a solution. Is a solution. So we can determine. Then we can determine the function. By use this equation from our classes lecture in the class, which as x equal to m x y, and then integrate this equation yield like this. Y t x plus g y, which is a partial differential equation, and then our m is equal to x plus sine y dx plus gx, which is m here. So integrate of this, we obtain that we integrate of x that respect to dx. So we can get 1/2 x squared, and this now sine y is a constant, like a constant, so we can get x plus sine y plus g y, and I note it as equation B. So in other step 4 is try to determine the function g y. Function gy by use this equation, the derivative of the solution, that we suppose f x y is equal to n x y, which I substitute as x y from equation B that we have seen in the above into this equation. So we can get that 1/2 plus x sine y plus g is equal to n. Our nx is x cos y minus, where that is come from, it is because from here this is the nx. So we can do this differential equation, which is differential derivative of this function with respect to y. So we get it as a 0, while this function derivative of this function with respect to dy, so we can get it as x cos y, and then d over dy gy, it's equal to x cos y minus 2. Note that I write this. This means that a derivative of g, which is not a partial now, and it only respect to y. So I can get we can use this one to eliminate it, and we get d over dy gy is equal to minus 3. So we can find the function g by integrate, which is gy is the integrate of minus 2y dy, which is equal to y squared plus z0. Okay, so now we can find the function g. So, and the next step is substitute gy equal to minus this into equation B to get the result that sxy is equal to x sine x and minus y power 2 plus 0, because we suppose that this is a solution that is equal to c value, so we can write it C equal to 1 over 2x. Like this, or another way we can write it as y square is equal to 1 over 2 sine y is plus c0 minus c, and let c1 is equal to c0 minus c. So the final answer is sine y plus c1, which it is an implicit solution. That's it.